Hi kids, this is a video that's going to walk you through how you make fixes to the skills test, which you're going to get returned to you today in class. The first thing is you've got to show your work, and the next thing is you have to do this on a fixed page. Fixed page looks like this. You can fix up to 5 problems per fixed page. I will be solving similar problems and walking you through how to solve those. Not showing the actual problem, but you can use the problems that I'm going over to help you fix the actual problems that you missed. The way you can use this video is move ahead if you need to the problem number that you missed. So number 1, I'm solving a problem similar to number 1. The main idea when the problem is written sideways is you have to rewrite it lining up your place value. The ones need to be added together, the tens, the hundreds, and so on. Now it's all lined up. I'm adding the ones, the tens, and the hundreds are being combined together. 2 and 4 is 6, and 7 is 13, carry the 1. 6 and 8 is 14, plus 6 is 20, 11 and 5 is 6. I get 5,603. Again, that's not the same problem you had on the quiz, but if you follow this strategy, you can make the fix. Question 2. Again, it's written horizontal or side to side. First thing I'm going to do is rewrite it so I can work with it. I can't subtract 4, take away 8, and there's nothing next door to borrow, here or here. I have to go all the way out to the 5, borrow from the 5. Now I'm borrowing back across. So this turns into a 10, but only briefly. It becomes a 10, but then I need to borrow from the 10 to make that number a 10. Only stays a 10 briefly again. Now I've done the borrowing and I'm ready to subtract. 14 take away 8 is 6. 9 take away 8 is 1. 9 subtract 9 is 0. And 4 subtract 2 is 2. Number 3. Multiplication, multi-digit. Rewrite it so you can work with it, and if one number has more numbers than the other, put that number on top. It's a little bit less work. The pattern I'm going to multiply now is this. I'm going to show this using the traditional algorithm. The pattern is, I'm going to multiply 7 times 9, 7 times 3, 7 times 4 on the first row. Second row, I start under the 5, and I'm going to do 5 times 9, 5 times 3, and 5 times 4. Here's what it looks like. 7 times 9 is 63. 3 there. 6 gets regrouped. 7 times 3 is 21, plus 6 is 27. 7 times 4 is 28, plus 2 is 30. That's my first row. Second row, I need to put a 0 placeholder because I need to start under the 5. Crossing these out. 5 times 9 is 45. 5 times 3 is 15, plus that 4 is 19. And 5 times 4 is 20, plus the 1 is 21. Now, I'm ready to add. $25,023. I check it on a calculator. If it's right, I move on. If it's not, I'm going to go back and check, did I copy the problem right? And check my math. Question 4. Long dividing. Again, it's written sideways. First thing I'm going to do is rewrite it so I can solve it. In division, the first number, if it's written sideways, 878 divided by 5, first number always goes on the inside. Doesn't matter which one's bigger. This is always the pattern. Now I'm going to follow this. Divide, multiply, subtract, check, and bring down. Those are my long division steps. You may have heard a saying to help you remember these steps. Does McDonald's sell cheeseburgers? But in math, divide, multiply, subtract, check, bring down. I'm going to do this digit by digit. So I'm going to only think of how many times does 5 go into 8. That's my divide, 1 time. 1 times 5, that's my multiply. 1 times 5 is 5. Now I'm subtracting. Next step is check. I'm checking. Is this number, after I subtracted, smaller than this one? If it is, you can move on. If it's not, did something wrong. It is, so I can move on. The B is bring down. After I bring down, I go back to the top. It creates a loop. I'm back to divide. How many 5s go into 37? 7 times. Multiply. 7 times 5 is 35. Subtract. Is 2 smaller than 5? Yes. Bring down. Back to the top, divide. How many 5s go into 28? 5 times. 5 times 5 is 25. I don't have any more numbers to bring down. So one answer I could have is 175, remainder 3. I could have also changed the remainder into a fraction amount. That answer would have been 175 and 3/5. I could have also changed the remainder into a decimal amount, and that would have looked like this, 175.8. All 3 of those answers I would accept for this problem. Moving on to question 5. Adding decimals. The big idea when you're adding or subtracting decimals is the decimals have to be lined up. I'm going to rewrite it so that they are. You can fill in gaps with zeros if you choose. So I could put a 0 right here. Now I'm just adding. My decimal comes straight down. 0 and 8 is 8. 4 and 9 is 13. Carry the 1. 4.38. Same strategy for number 6. It's subtracting decimals. I'm going to rewrite it. 3.7. Subtract 1.93. Now, when you're subtracting, the order matters. 3.7, the first number, has to be on top. When you're adding, the order doesn't matter. Subtracting, it sure does. 3.7, take away 1.93, has to look like this. Again, I can fill in with a 0. Now I'm subtracting. 0 take away 3, I can't do that. I'm borrowing. 10 take away 3 is 7. 6 take away 9, I cannot do, so I'm borrowing. 16 take away 9 is 7. Decimal comes straight down. 2 take away 1 is 1. Okay, moving on to question 7. Adding fractions. The big idea when you're adding or subtracting fractions is you have to get common denominators. This is a 4, that's a 6. They are not the same. I'm going to rewrite this problem so it's up and down, and I'm going to be changing these fractions so that they have common denominators. If I count by 4s and I count by 6s, I want the first match is the best pick. 4, 8, 12, 16, 20, and so on. 6, 12. There's my first match. If I count by 4s and I count by 6s, 12 is my least common multiple or least common denominator. Now I'm going to convert this fraction. How did I go from 4 to get to 12? I multiplied it by 3. I've got to do that to my numerator. 2 times 3 is 6. Same process for the 5/6. How did I go from 6 to get to 12? I did times 2. I've got to multiply my numerator times 2. I get 10. Now I'm ready to add 6/12 combined with 10/12. Same denominator. They're both 12s. All I do is add numerators. I get 16/12. Improper fraction because the numerator is greater than the denominator. It's top heavy. I can simplify this in a couple of ways. The largest number that goes into both of these is 4, so I can change it into 4/3. I can then further simplify that into 4/3 is the same thing as 1 and 1/3. So all those answers are the same. That's fully simplified. Okay, number 8. Subtracting fractions. Again, I need common denominators. And I'm going to rewrite it. 1/3 and 1/6. I need common denominators. This time, my best pick would be to change them into 1/6, which this one already is. But some of you know that you can multiply denominators. That's always going to give you a common denominator. I'm going to do that on this problem. 3 times 6 is 18. I'm going to change both of them into 18ths. How did I go from 3 to get to 18? Multiplied by 6. How did I go from 6 to get to 18? Multiplied by 3. So now I've got 6/18 subtract 15/18. Well, I can't subtract 6, take away 15. I need to borrow 1 whole from the 4 wholes. But when I bring over that whole, I'm bringing 1 whole over here to the fraction side, but when I bring that over, it comes over as 18/18. 18/18 is the same thing as 1. That's the 1 whole that I borrowed. I need to put these two together. I had 6/18, but I borrowed 18/18. So I combine these. 18/18 and 6/18 turns into 24/18. Now I can subtract. 24 subtract 15, I can do that. That turns into 9/18. 3 take away nothing is 3. And simplifying 9/18 all the way, I get 3.5. Next problem, number 9. Improper fraction into a mixed number. This is improper because the numerator, the top number, is greater than the denominator, the bottom number. For understanding fractions, always start with the denominator. Always, always. That 5, right away in my head I would be thinking this. That 5 tells me in 1 whole pizza, I've got 5 slices. If that was a 4, I would have 4. If this was a 10, I'd have 10 slices. If it was 100, I'd have 100 slices. Always start with the denominator. The 12 numerator tells me how many pieces I need to shade in. Well, I need to shade in 12. So 1, 2, 3, 4, 5. I can't shade in anymore, so what do? Make a new pizza. 6, 7, 8, 9, 10. Make another one. 11, 12. There's my picture for 12/5. Now, what is that also a picture of? How many full pizzas do I have? 1, 2. It's 2. And how much pizza is this one? It's 2 whole pizzas and 2/5 of the next one. So 12/5 is the same thing as 2 2/5. Another way you can do that is to divide. How many times does 5 go into 12? 2 whole times. That gets you to 10. What's left over? 2 is left over, and your denominator stays the same. But if you're not sure, drawing is always a good way to help your thinking. Number 10. This time we have a mixed number, 3 3/4, and we're changing it to an improper fraction. I'm going to draw 3 3/4. So I've got 1, 2, 3 holes. That's 3 holes and 3/4. So 1, 2, 3. There's my 3/4. These are holes, but I can also divide them into fourths, but they're holes. These are all shaded in. There's my model or my drawing for 3 3/4. Well, now if I want just fourths, an improper fraction, how many fourths do I have? I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've got 15 fourths. Number 11, area of a dog pen that is 3 meters by 2 meters. The word area, when you hear the word area, you should think squares. Always counting squares with area. I'm going to draw a dog pen. It's 3 meters on this side, 2 meters on this side. There it is. How many square units do I have? 1, 2, 3, 4, 5, 6. The shortcut for a rectangle is length times width. I have 6 meters squared. 6 meters in my dog pen. Last one, number 12. The perimeter of a 3 by 2 dog pen. Perimeter, always think, how much fence do I need to make a perimeter? I'm going to draw 3 by 2. There's my dog pen. The area is 6 square meters, but I want perimeter. I want fence. If I'm building a fence and my fence units are a meter, how many meters of fence do I need? Well, I would need 1 meter right there. I would need another meter here, here, here. I'm just going all the way around this dog pen. I would need a section of fence there, 1 there, 1 there, 1 there, 1 there, and 1 there. There's my fence around the dog pen. 2 units of fence, 2 units of fence, 3 units of fence, 3 units of fence. When I put all those together, there's many ways I could do that. When I add it all together, I'm going to get, what is that? 10 units of fence, or 10 meters of fence. That's how much fence I would need for the dog pen. I sure hope this video has helped you know what to do to fix the problems. If you still need more help, please let me know. Thank you very much.